Good evening. This is Ken Long from Tortoise Capital with a review of a logic problem that we worked on today in the chat room, November 28th, 2012. We were talking about standardizing your trading plan and working on techniques that allow you to control the kinds of errors that you can make, or to minimize the negative consequences of the errors by standardizing your approach. And the idea was similar to that in golf, where you want to groove your swing and hit the ball the same way each time, and then adjust your aiming point based on the characteristics of the standardized controlled flight of the ball. And it reminded me of a technique that we use in land navigation before the days of global positioning system. And the logic problem is this. Suppose you're located in a wooded area. It's difficult terrain, thickly wooded, rolling hills, lots of streams and gullies to make it hard to walk a straight line. And you've got to traverse 20 kilometers and reach an objective along the only east-west road in the forest. Now you've got to be at that objective in 11 hours, and you know from practice that you can cross this type of terrain at 2 kilometers an hour. You have a magnetic compass to use, and you've accounted for the difference between true north, which is north on a map, and magnetic north. And you know that after controlling for that, that if you could walk a perfectly straight line on an azimuth or magnetic direction of 0 degrees north, you would arrive exactly at your objective. You know furthermore from practice that when using a compass and trying to walk a straight line in this type of terrain, your left and right deviation per 100 meters is 3 meters. And you're equally likely to be off to the left or to the right of your intended direction per those 100 meters. Your technique for walking cross country while land navigating is you stand still and you look forward through your compass along your designated azimuth, or your direction of march, which is measured in degrees. You look ahead until you can see a recognizable landmark like a tree or a stone or a ground feature, and you move forward towards it as directly as you can, counting your paces, because you know how many steps per 100 meters you take. And you can do something like tie a knot in a string each 100 meters you travel, or move a rock from one pocket to the other, keep track on your fingers, or a notch on a stick, so that you can keep track of each 100 meters you travel, so you have an estimate of how far you've gone. And so now the logic problem is to describe your strategy for accomplishing your mission. You know that you can cover the distance from you to the objective in 10 hours, and you have 1 hour of slack. But if you were to walk directly towards that object, and when you get there it's not there, you won't know which way to turn, left or right, because you're not sure where the accumulated error of those 200 segments has placed you. And so you could end up wasting time if you pick the wrong way and then have to backtrack. So we want to find a way that will allow us to quickly get to that objective. That's the logic problem. So you can stop the movie here. Now the solution is known as the deliberate offset method. And since you know you can be off by as much as 3 meters per 100, the maximum distance you could be off over a 20-kilometer route is 600 meters. In other words, if you were off 3 meters each and every time, and it was always in the same direction, you could be off 600 meters. So what you want to do is pick a point to navigate towards that's 600 meters east or west of your desired target, and then go as quickly as you can to the road, and once you get there, you'll know that which direction you have to turn, and then you can move directly to the objective, and then you'll see it. Now, if you were uniformly wrong by 3 meters in the same direction on every leg, the most that you could be away from your objective then is 1,200 meters. So the 600 meters you offset, let's say in this case to the east, and then you happen to be off 200 times 3 meters, an additional 600 meters. The furthest you would have to walk is 1,200 meters from where you intersect the road to your objective. And because you can walk 2 kilometers an hour, you should be able to cover that distance in about 40 minutes. And then you still have a 20-minute slack time. And so that's the technique that we use for rapidly moving towards an objective, known as the deliberate offset method. In this case, we have acknowledged our errors, and we have incorporated it into our plan in such a way that we reduce the uncertainty of accomplishing our mission by taking into account our known errors and planning for them. So this is Ken Locke from Tortoise Capital. Thanks for your attention.